So this section's a lot about these things called sine and cosine, which are two functions, two trigonometric functions that are the basis of all these trig functions. In fact, these are related functions, and you'll see when we talk about like Pythagorean triples. They're also, I mean, they're co-functions, but I'm getting way ahead of myself. So there are definitions for any angle t. We can label the intersection of the terminal side of the unit circle by its coordinates x, y, as you see in the diagram here. So we have, here x, y for any angle t. We have a cosine t, a sine t. The coordinates x and y will be the outputs of the trigonometric functions f of t equals cosine t and f of t equals sine t, respectively. This means that x, so x equals a cosine t, and y is our sine t. So what I really want you to take from this is, see the vertical change, this vertical here is the y part, the horizontal is the x part. So if we had an angle that was more like this, you see they'd have a bigger x part than a y part. Or if we have an angle that's like this, we'd have a smaller x part than a y part. So just keep that in mind as we go forward into this topic. So unit circle is a circle that has a center at 0, 0, and its radius is 1. Hence unit, it's 1. Look at that. What's that all about? In a unit circle, the length of the intercepted arc is equal to the radian measure of the central angle of 1. Because it's, our c equals 2 pi r, and if r is 1, then c equals 2 pi. So, and think about our arc length, s equals r theta, and if r equals 1, then s equals theta. So think of that, reference back to 7.1. Let x, y be the endpoint on the unit circle of an arc of length s. The xy coordinates of this point can be described as the functions of the angle. So defining our sine and cosine functions. Sine function relates a real number t to the y coordinate of the point where the corresponding angle intercepts the unit circle, and cosine function of an angle t equals the x value of the endpoint on the unit circle of an arc of length t. So as we talked about here, so our sine is the y, our cosine is the x. So sine and cosine functions of t as a real number, endpoint x, y is in the unit circle corresponds to an angle of t, then x equals cosine t and y is sine t. So how to find the sine and cosine of an angle given a point P? The sine of t is equal to the y coordinate of the point P. I'm kind of saying the same thing over. I hope it's sticking. Cosine of t is equal to the x coordinate of the point t. So find our point P is the point on the unit circle corresponding to the angle t. Find cosine t and sine t. So our cosine t is going to be the x coordinate, which is 1/2, and our sine t is the y coordinate, which is the square root of 3/2. I want to also reference here that they're showing that this is the 1/2. That's 1/2, and then this is the square root of 3/2.